So welcome everyone. So today I'm going to present about how to enhancing RAG system. So my name is Cristofor Fiștic. I'm data scientist at Grid Dynamics, and I work on a RAG system for a financial company. But today I'm going to speak about more about different implementation, what we do in the project, because now we are further iteration of that RAG system. And also I'm going to speak about how other companies enhance their RAG system. So how many of you knows how RAG system works? Please raise your hands. Okay, so let's talk about agenda. So we'll do a quick refresh about what is RAG. So we will be on the same page. So you'll know the basic. And then we'll talk about some methods, how can improve our RAG system. And then will be question and answer when you can ask your question about my presentation. So please ask how many questions you want. So yeah, so let's start with what is RAG and why appears RAG. So we know LLMs, don't need to talk about them, and they are also limited by their pre-training data. So this means that they are limited to the trained data that was made in that period of time when they was trained. So this means that they cannot know all the answers, and they are limited on this. So this can this can make potentially outdated and inaccurate responses. So RAG system try to solve this by giving LLM the right context, how to answer the question. And how work the RAG system, you can see here's a diagram that show every step of how RAG system works. So we have two main phases. First phase is about how we prepare our knowledge base. RAG system, imagine it's like an open book exam, when a student can look in the book and find the right answer if he don't know the answer. So this is the same case. So first we need to prepare this knowledge base. So what we do, we have our documents, and because LLMs are limited by context window, we cannot fit all the documents in their context window. So what we do, we split them. And this made document chunks. After that, we transform them with embeddings and vector representation that enhance all the knowledge about the document chunks, and we can find their by context similarity. And we store this in vector database. This is a special database made for storing this type of vector representations. And now is the second phase. The second phase is about how we interact with our user. So a user give a question. What we do, we also use that embedding model, transform it in a representation of that semantic meaning, and then we try to use that vector to find the similar context from our database. What this gives us the documents that are relevant and are more, let's say, similar by context to the question we'll give user. And then we give to our LLM user question, that context, and the prompt. So in this way, LLM can use the context retrieved from vector database to respond that question. So this is how looks a naive RAG implementation, very simple. And because you can see the system is very complex, we have a lot of problems. And some of them are like poor retrieval, so we'll very hard find the right document embeddings from vector database, and bad chunking, because it's hard to split documents. You know all how these documents can look bad. And they are also the same problems that have LLMs. And now let's start with some methods that we'll talk how to increase this performance. And let's start first with how we prepare documents. So with chunking. So the problem is that we split the documents just by let's say, fixed length, then we can create some noise and we can lose some context. So what we can do? So one of the strategies is sentence-based chunking. What this means? We split just by sentence. So you can see in the example from the diagram, we just split them by sentence. And why this, let's say, the advantage of this is very simple. It's just one line of code. And the problem is that we can lose some context because, you know, sentence can be correlated, and also it can vary by length. So one sentence can be shorter, other bigger, so the content will be different length. Other variant is paragraph-based. So basically, we split by paragraphs. Yes, it's the same, let's say, natural splitting, so it's very easy to do, and it can provide more context. But the problem is that the size of paragraph also can vary, and let's say, some paragraph can be more than the context length of our embedding model. So you cannot make all paragraph in one just embedding transformation. The next is slicing window chunking. So you can see we have like our sentence, and we can give one another sentence, so you have like an overlap. So you can see in the example, we have a red box where you have sentence 1 and 2, and the green one we have sentence 2 and 3. So sentence 2 is the overlapping sentence. What this do? This increase the, let's say, the probability that they will have like continuity in context of chunking, and also help just to retrieve the more better understanding when that phrase was given. So the context will be more, let's say, have a more chance to be better. But the problem is that we are overlapping content. So this can lead to additional duplication of information. So this will increase, like, let's say, our storage using and the processing power for this. Now, the next method is semantic checking. So what is semantic checking? This is basically use a model that can split our document by same topics or by same semantics. So the disadvantage of this is that we need to use a very advanced NLP model that can find these topics. So you can see in the example, we have two topics. First is introduction of Lily, and the second, discover of a key. So the same text is split by just two different topics. And the advantage of this is that it preserves the semantic meanings, so it's very good at this. The problem is that it's time consuming and, how I say, need an NLP model advanced. And now one of the other methods is recursive chunking. So we know all the documents, they have a very difficult structure. And basically this example of a book, The Adventure of Lily, and you can see it can have chapters, section, and paragraphs. So basically we split every document by, let's say, this book by their structure representation. And this means that we have like a big chunk for all, let's say, book, then one big chunk for chapter 1, then one big chunk for section 1, and one big chunk for paragraph 1. So what this helps? This helps to remain the context, the structural relationship between these parts. So this means that we can find the right chapter that responds to our question and the right subsection. And this can lead to the thing that our model can respond better to understand, let's say, all the context. The problem is that also in paragraph 1.1.1, for example, they can lose still the context because it can be very small. So basically, this can help us find the right chunk from document, but this doesn't mean that we can use the right context. And it requires to handle all these, let's say, hierarchical structure. So it's more harder to save in the vector database. And this causes a lot of, let's say, additional complexity in the code. So these are some methods that I want to talk. And now, let's say, this is a table that represents all the methods that I know. And you can see there, let's say, there is two important columns: context preservation, implementation, complexity. So you can see in the way we increase the chance that you have a high context preservation, you can see that implementation also increase. So the higher chance you want a better model to have a better context, then the complexity also increase. And let's say the more popular methods are sliding window and semantic chunking, and also recursive chunking. These are the, let's say, the most popular method, but it depends on your project. So it can be everything that you want. It depends on your requirements. And how to choose the right document chunking strategy. So how I say, it's not exist a best strategy or a best size. It depends on your query, data type, and embedding model. So the common range is between 256 and 512 tokens, because this is the size of embedding model that transform, but it differs by different, let's say, embedding models. So try different embedding models because they have different understanding of a word, balance between efficiency and context, and just experiment, try different methods because there is not a right strategy. And now let's go to another method also required about the text. It's metadata. So what is metadata? So imagine that we have, let's say, a lot of documents, like in my case, about financial analysis for the same company. So it is from different years. And what we try to do, we try to find, let's say, give me the last document about NVIDIA revenue. So you can see that, for example, if you have about NVIDIA company, let's say 3 documents from 3 different years, it can happen that the document from 2000, let's say 21, should be first in what find similarity, but it's not the latest. So that response will be outdated. So how we can fix this? We can lose something like metadata to enhance this. Basically, you can have some metadata like, let's say, date, source, something like some tags. So what this can help to, let's say, to filter the data that we have basically by date. And in this way, we'll just speed our system and have a chance just the right chunk came to our LLM. So you can see I tried a test. Basically, I used some basic documents from our database and try just a naive RAG with metadata and without metadata. And you can see how it increase accuracy. Why this goes? How I say, we have a lot of documents that are from same companies by different years. So just by filtering by years, increase a lot the precision of our system. And a very important key aspect is that all the, let's say, this metadata depends on how it's good quality and how it's consistency. So why this is important? Because let's say like this, if metadata is wrong, then you cannot know if it's not correct. So this means that all the filtering will go wrong. So just a small tip, use LLMs to create the metadata. This also can help, but make human verified so it will be correct. Now, let's go through other part of the RAG system. It's question. So you can see how in this tweet it say, basically one of the problems that we have in the RAG system is that question can be ambiguous. You all know when people ask you some question, it's hard to understand what they want. So believe me, LLMs also hard to understand what you want. So what is the problem? Because sometimes we can write ambiguous questions, so it'll be hard to understand what you want. And also this question is used for finding relative documents. So it's more harder to them to understand and to find the right document. So what we can do, we have different methods. We have, let's say, more abstract methods that go just, let's say, more about the domain of a question, and less abstract, that go more narrow. And we have some rewriting questions that try to improve the question by user. So let's go to understand some of these methods. So yeah, first of all, let's speak about multi-query. So what is multi-query? We have a query from user, and we transform this query in 5 different questions. What is the intuition beside this, let's say, proposed? It's just that when we have different question, there is a big chance that this question will go to different, let's say, chunk representation for vector database. So this increases the chance that we will receive the right documents from our vector database. And this is how it works. So basically, see, we have a question. We create 3 different questions based on that question. We try to receive all relevant chunks from vector database, and then all these documents will go to the LLM model to make the answer. But one problem that you can see, it's a lot of documents, so they are context limits. So what we do? And here's come RAG Fusion. Okay, but now let's speak about one example. So it's this part of a, let's say in the slide, you can see the general prompt. So this is the prompt that you use system prompt to generate this type of question. You can see the most important thing is that to say to the LLM that you use this for distance-based similarity search. Why this is important to use in the prompt? Because it's make LLM to use different words and to make them more different, so it'll be better at semantic similarity. And you can see the original question was what task is the composition for LLM agents, and you can see the 5 different questions that it generates basically from this question. So all this was used by just is a real example that we use, and you can see that all these questions use different words, so this can increase the chance of finding the right documents. Okay, so now about RAG Fusion. So it's the same like multi-query. The difference is in this, how we fuse all documents. So we use something named reciprocal rank fusion. So what is this? Yeah, it's a formula. Okay, so what we use, so basically it's the sum of, let's say, of 1 divided by k, where k is a constant, and rank is the rank of document in the list. And why k is a constant is just to avoid division and to not influence by low rank documents. And the typical value for this is 16. So what we do? So you can see we have like 3 queries and 3 different lists of retrieved documents. So you can see we are different rank and different list. And we calculate for every of them this score. And then we just sum the score for each document in different list. So based on that, we just sort them and find what document is the best. This improves a lot of the system and find the right documents for your, let's say, LLM, because we are context limits. So we need to filter what documents we obtain. Now let's go to another method is the composition. So what is the composition? This is a narrow-based method. So what we try to do, we have a first question to our LLM and we give an answer. And LLM finds that this answer is not good. It's not answering the question that have user. So it generates the second question to find more narrow-based knowledge. And then so on till it finds the right question and the right answer. And this is like how it works. So basically you retrieve all of the document and then generate answer, document, and answer. So you can see an example. So we have a diagram that show like the question was in what country was lost gravity manufactured, and we obtained from our database the lost gravity was manufactured by Mack Wrights. But it's not giving the answer. It's not giving in what country. So what do LLMs is generate a question from where is Mark Wright's company, and it obtains the result from database. The Mark Wright's company is a company from Germany. So in this way, we obtain the country, and then he generates the answer. That answer is Germany. So in this way, he found the right answer from our database. Besides, in the first phase, he didn't retrieve the right chunk from the database. Okay, and let's pick another method, rewriting. So imagine our user writes something like this. When asked about when John Doe about something from our company, and we responded, and then he asked about Emily Doe. So if you go to embed this phrase, it not give nothing, because you don't give a context, and it's very low. let's say it's just 4 words. So what we try to do, we try to rewrite it. And how we do this, we try to give like the context of what was in conversation, because basically RAG is also a chat system. So what we try to do, you can see the prompt, we just give the following conversation, rewrite the last user input. So you can see after this, the last question for user was transforming like, when was the last time Emily Doi bought something for us? So this gives a more context about what we can retrieve. And this helps just our system to retrieve the right chunks. And query transformation is not just about rewriting user queries in the question. It can rewrite it in just a sentence. You can see in our case, for example, what we use in our system. For example, if you ask, how did the tech stock perform last quarter? You can read it in like in Q1 2025 technology sector, stock performance, analysis, financial metrics. So it just gives you more words for better retrieving. So this is improve a lot our system. And also you can use just small generative models to rewrite the queries, so you can just save on costs. And let's speak about another method, so step-back prompting. Step-back prompting, it's just the principle behind more, let's say, STEM-oriented RAG system. Why is that proposed? Because LLMs can be lost in details. So basically, if you go in something that are very, let's say, complicated, LLM can lose some context. So step-back prompting tries to go more abstract. So basically, when user give a question, you use the original question to ask a high-level information about this question. So basically, you try to get all the understanding from that question before you answer it. So it's very effective in QA system. And you can see in the slide, it's some example of system prompt, how it looks like, and also some example of original question and step-back question, how it generates. And let's speak about some real examples. So you can see this time data set we use from, and this is from original, let's say, paper of this method. And you can see, for example, in the first question, we have about currency askew, what we play for what teams. And you can see in the first example, RAG didn't answer correctly. It say Benfica, but if you go and ask all the history, where play Carlos askew, then it give a right question. Because the problem is retrieving. Once again, when you retrieve documents, can happen something, let's say, not correct. And in this case, if you give the context of all where he play all teams, then it's more bigger chance that LLM from that context can find the right answer, because we use just understanding of LLMs over words. Okay, and let's speak about how this improved. So I found some, let's say, research about how other companies improve their system by this technique. So you can see Bloomberg News user rewriting, and they improve their system by 70%. Notion AI used for their RAG system based on the Notion that people have in their database, and it's also used RAG Fusion, so it improved by 50%. And step-back prompt was used by Google because it's implemented by Google and was proposed by them. And the composition was used by Alibaba Taobao. Taobao is a system like, let's say, it's a special magazine in China, and you can see that the composition is long, especially for long-tail queries. And you can ask, but I want to use many of these methods simultaneously, or how you can ask. So how make our system make this? They use a model specific for classification of a query. So basically, if it's long tail query, then you can use decomposition. If it's something that you can know that it's more, let's say, better for stem binding prompting, so you can use also this. So basically, before you try to make some transformation with a query, you just classify them and apply the right method. So now let's go with method that can improve, let's say, also the retrieval. So first, it's hypothetical document embedding. So you can see we have something like we try our query to find the right chunk. But this is not always good. Why? Because there can be a semantic gap between our query embedding and answer embedding. So what we try to do, we try to use LLMs to generate first the hypothetical answer and then embed that hypothetical answer. So this increases the chances to find a real answer. So basically, the idea beside this is the answer-to-answer similarity. It's bigger than query-to-answer similarity. And you can see in this diagram, we have just some question. We go to ChatGPT, make some hypothetical response, and then try to use this response to find the real document from vector database. The next method will be focused on how we improve our search from our RAG system. So first method, but let's speak just about increasing. So we have context precision, answer relevance, and fairness. And you can see how a naive RAG can improve the system just by using this method. So why it's so good, the hide method? Because it's just improve, let's say, the part of retrieving the right document. So just finding the right document increase, let's say, the context precision and also the answer will give LLMs. And now how I say, it's not about improving the search. So let's speak about how you can improve our search. So first method that you can use is hybrid search. So you can see in all the cases that I talked till now, we use the semantic similarity. But semantic similarity is not always good. In case of my RAG system, we have this problem that we have a lot of financial documents that are similar by structure. So they differ just by the name of company and some words, maybe some numbers, but they are the same. And when we try to make, let's say, similarity by their semantics, we retrieve a lot of documents that are from wrong companies. And why this happened? Because, let's say, the structure of documents, it's very similar. So how we improve this? We use hybrid search. Basically use also the keyword search. And one of keywords was company name. So in this way, we increase a lot the, let's say, the accuracy of retrieving the right chunk. And one best part of this, you can use weighted scores. So what this means, we can improve, let's say, the meaning of some of searches. So if you want keyword search to be more important, then you can give a bigger weight to this part of a search. And you can see how let's say, this is a real example from our system. So you can see how average fail retrieval has decreased by half by using just this method in our case. And now let's talk about a new method from Anthropic that was published in September 2024. So it's used contextual retrieval. So how it works? Imagine that our user asks some question like, when was the revenue growth for example corp in Q2 2023? And the relevant chunk that we need from our database is this phrase: the company revenue grew by 3% over the previous quarter. So you can see this chunk is very, let's say, not giving a lot of details, so it'll be hard to find them from vector database, but we need to find them. So what we can do? So Anthropic proposed this method, so we can create something like context chunk. So what is context chunk? Basically, we give our chunk to a model. In this case, it's Anthropic Cloud. And what we do, we just make a context of that chunk where is the document situated. So basically, this is a description of 5,100 tokens that say about what is the document and what the chunk is situated in that document. And this increases the understanding from what is that chunk. And let's go to the example that I gave in the beginning. So you can see the context that was generated by LLM is the chunk is from a SEC filing example of Corp company's performance in Q2, and the previous quarter revenue was 340 million. Yeah. So you can see this chunk is put in original chunk, so you have more bigger chunk, but this increases the accuracy of retrieving the right document because that chunk now have a lot of information that can increase our retrieval. And now let's speak about a more complicated, let's say, method re-ranking. But before that, let's just speak about how we can improve our system. So you can see if we use context embedding, it's just increasing the score. So you can see it's just going more, the fail retrievers go down. So you can see that after we have just used the context embedding, the just searching by embedding is improving also, but with using the hybrid search is improving more. So now we have like 5%. And how I say re-ranking. So what is re-ranking? We have a problem that LLM context is limited. So we cannot fill all the documents in the, let's say, in the context. So the problem is that when we receive the documents from our database, they cannot be in correct order. So what we can do, we just try to rewrite them by the right, let's say, meaning. So what you can use some specialized model for this, or some APIs that just use the type of models, or just some LLMs. And how this works? So you can see this is just usual RAG system flow, what we speak at the beginning. So you have a query, we find from the database, and then we just transform it. And you can see we have some vectors, and you can see the green one is that right, let's say, document that we go through the LLM to give answer. So we have like top 5 from top 10 receiver from our database. And it happens that often they are not so good. So basically, it's because something, let's say, the context is not very right, and LLM cannot, let's say, understand always the correct from one context, why it was given by our search. So what can do re-ranking? So basically use another method, but just try to see if that document it's good fitting with our question. So it's giving like a score. Like the prompt can be, give me a score, how good is that document to answer that question. And then you can just reward them by that score. And you can see in this example, the order is totally different. So now the top 5 documents are totally different from what is the beginning. So this also improve our system a lot. So you can see the difference. So just by using re-ranking and with hybrid search, you also improve our system. But using with context embedding and also re-ranking, it's improved like 4 till 4%. So making all this manipulation, we improve our system by 5 times. Just retrieving process, so finding the right chunk documents from vector database. And now let's go to speak about a very important thing in RAG system is the prompt. So how we can improve our prompt? So first, I will propose you to use I don't know instruction. You know, LLMs are trained a lot to answer a question. So this is why they can hallucinate. And if they don't know question, they will try to answer it. And if you use just this syntax, say I don't know, this can increase a lot. And there is a special benchmark for this that compare different models, how they're good at saying that they don't know something. And this will just improve the accuracy of your, let's say, model. Also use role playing. So in our case, it acts as financial advisor. This use just use the right, let's say, words, the right acronyms, and just set the right tone. Also, just specify the format. So in this case, for example, Markdown. So by using the right format, it can improve, let's say, how it looks like, how clear it's to understand, and just, let's say, it should be more user-friendly. And use chain of thoughts. Why it's important? Because how I say, sometimes user can give a very big question, and just thinking step by step how to answer that question can improve, let's say, the answer. And let's speak about how you can improve hallucinations, because RAG system also can have this problem. So, you know, a very simple trick to improve hallucination is just to save a model to quote or cite the sources. So basically, if you just save this thing to the model, it makes it self-verify because you need to find where it's from the context it found this information. So this improves a lot, let's say, the faithfulness. You can see I make a simple RAG case of naive and just put this prompt and improves a lot of faithfulness. And also, let's say one specific type of RAG is self-RAG. So what is self-RAG is just, it can reflect in all responses. Basically, it's just turn a new, let's say, request when it's verifying if that answer have the right citations. So it just verify if it's working. And verification is just about using something like LLM as a judge. So basically use another model that will make his task just to verify if the citation is writing. And all these 3 cases are just good enough to improve hallucination, and we are used by a lot of systems. So let's recap what we studied today. So yeah, we have different methods for how we can improve our data. So we use advanced chunking metadata filters. We use for prompting query transformation and hypothetical answer. For retrieval, we learn about hybrid search, context embedding, and rewriting. And for grounding, we learn about verification, self-correction, and citation. And in conclusion, so naive RAG is not often useful. It's not good for production. But what you can do, we just can start from the beginning and iterate through it. So you can try to improve it. And the best part is that all these methods can be used together. So we can use all, let's say, combine and just to improve our system. The problem is that we need to experiment and to evaluate every time how good our RAG system can go. And don't forget about trade-offs about performance, latency, and cost, because all this improvement can increase your cost and the latency of your system. So this all can, let's say, it depends of what requirements you have. And thank you for listening. Hope you learned something new. So if you have questions, please ask.
Frameworks of evaluating the RAG performance.
Okay,
What
so
do you use?
there are 2 popular frameworks, MLflow and Ragas. So basically, we use Ragas. There is, if you know, there is a special framework for testing RAG systems. In Ragas, we have different metrics. Let's say, the more harder part, you need to create the dataset. So in our case, we create a dataset of 300 questions with the right answer from advisors, and we just verify on it. So basically, you have like let's say, a pipeline that goes every time we improve something in our RAG system and verify based on it, like how it's working. And we use faithfulness, we use precision at 12 and 20. And we also use, let's say, something like MMR and something like hit rate. So basically, these are the scores that we use just to see how good is our system. But also, it's very popular in MLflow from what I know. So in MLflow, you can use like LLM as a judge also for this, and you can create some specific pipeline also for this, like using Ragas and other systems.
Vector database. What is your experience? Which one is the best? Which one?
Okay, so in our case, we use a vector database that it's, let's say, we have a partnership of a company. I cannot say his name, the company, but we use that database. But in let's say, in real case, it depends on your data. Basically, there are some, let's say, vector databases that are very fast, like I don't know, Qdran, and other vector database that are just, let's say, it depends on how you want to create the index of your, let's say, documents that you save in the database. So we have different technology in indexing, and also you need to look at the search, what they have, because, for example, hybrid search is not implementing in all the vector database. So it very much depends on, let's say, what type of search you want to use and how to index. I know that, let's say, FICE is very easy to use, like it's used for POC concepts a lot because it's open source and have a lot of methods. It's very important also to know about a vector database if you want to use open source or paid version, because there are a lot of paid versions that have, let's say, some improvements in, because we are just, let's say, have maintenance, and this helps them to be just more focused on not.
You cannot say the name of a company. Can I ask what framework you're using, like LangChain, LangGraph, is it something?
LangChain.
LangChain, okay. And I have a question regarding semantic chunking. I know that LangChain has it, but I've never used it. So have you any experience? Because most of the material using recursive text splitting, but I've never tried.
Okay, we tried it. It's not working so good. But in these cases, in our case, maybe it's not so good because our documents look very bad. So basically, we are, let's say, a lot of images and a lot of tables because they're financial documents. I know, let's say, from our experimentation, it was good, like at, let's say, 70% of documents, the right splitting, but it's taking a lot of time. So in our case, it took like, I think, a day. We just run it through all the database, and but I cannot say how good it will perform in your case, but in our case, it didn't work.
And regarding the size of a chunk, certain LLMs have very small context regarding. Have you considered, for example, to relate size of a chunk to a possible context of an LLM? For example, no more than 5 chunks of the size of 100 tokens.
Yes. So this is.
Sense?
Yeah, so this is how you choose the top K that you retrieve from vector database. So how I say in the, let's say, okay, so basically now, let's say one of what I give you in one of the diagram, we have like, we retrieve top 10 documents, then we give to LLM top 5. So basically, how many of documents from that what you retrieve from database is passing through your language model depends on the context. If you use Gemini, it's a lot of context, so you can pass top 50, I don't know. But if it's small, then yeah, you need to, how we do, in our case, it's more limited by embedding model. So use how many contexts can retrieve our embedding model. So our embedding model is limited to 512. So this is the size chunk.
Maybe it's an open information. Where did you take your embedding model? Is this open source?
Yeah, it's open source from Hugging Face.
And another question, what if the prompt is completely irrelevant to the question or to a chat which you're developing? Someone is asking about the Netflix, while the documents are about finance.
Okay, for this case, we have guardrails. So I didn't speak about this in the presentation. Believe me, I cut a lot of information from it. It's just, let's say like this, guardrails, it's more about how you can improve, like, let's say user to not give the wrong question. So we have, let's say, LLM guardrail that can just verify if the question is right about what we have in our, let's say, knowledge base. So if it's giving, no, it's giving like, please answer the right question. I cannot ask you about Netflix or something like this.
And you mentioned step-back prompting.
Yeah.
I don't know what it means. Is this like a chat which asks you to specify more exact information?
No. So step-back prompting, it's more about the fact that when you have a question, for example, you can go, let's say, when you try to receive from vector database, you may have the problem that you don't receive the right context. So what do step-back prompting is trying to give a more general question. So for example, in the presentation was case about Carlos Askew. So he's a player from football player, and it was a question about when he played for, let's say, what team he played in 2013. So LLMs retrieve the right context, but was the wrong answer. So what we did is generate a more abstract question about where he played and what his life. So when receiving this context from vector database, it's a bigger chance you receive all the information when he play everywhere. And then when you feed that context to LLM, he can choose the right, let's say, peak of information. Because when you give just the wrong chunk, it cannot give the right answer.
If you don't mind.
Yeah, no problem.
And regarding height and some other tools, essentially your pipeline become larger.
Yeah.
More complicated. Have you considered retrieval time, for example?
Yeah.
After addition of one.
Yeah. So
tolerance level or benchmark you would suggest?
between 4 and 5 seconds in our case. For one user input, the waiting is between 4 and 5 seconds. So this is the limit of our requirement. So we try to improve it a lot. Our backend engineers want a lot of improving this system. So yeah, but yeah, it's between 4 and 5 seconds.
And what element of the pipeline took the most time?
Re-ranking. Yeah.
Okay. And one more question. You mentioned that you are working with the tables. I haven't tried it, but I know it must be extremely complicated. Do you solve it through specific library with a PDF file? Because I know that in order to retrieve table, you kind of get the coordinates of the image and then you need to extract the information and this something.
In our case, help multimodal. So basically use a multimodal, but LLMs that is multimodal, so he can understand tables. And in our case, this help a lot to improve. Before that, we use a specific, let's say, chunking by different multimodal contexts. So you chunk images separated and tables, but now just because you use ChatGPT, it's helping, like, let's say, he understands very good tables and images, all the things. So it's just working like this.
So it's not like specific PDF
No.
library, it's an LLM.
Yeah. In our case, it works like this.
And the last one, regarding the rerouting as a final stage, which should be the longest part, is rerouting done by LLM or you have specific value which or KPI?
In our case, it's LLM. I say we give just a prompt, just verify, let's say, how good is that chunk to this specific question. And yeah, yeah, and it's let's say like this. It's given like a score. So use like something like LLM as a judge. You give him a score of relevance, and then we just sort by that score, and that go through our.
Have you considered using? There's another popular technique. It's knowledge graphs in combination with the RAG system. Have you tried that?
Yeah, but for other project. So in our case, let's say like this. We use this for financial advisor. So in this way, this document, let's say, knowledge graph is good when we have some relation between documents. So we have, like, say, let's say, some knowledge relationship. But in our case, it's these documents, let's say, are not related. We are from different companies with different prospects. So knowledge graph will not work so good. But we use this for other thing. We have, let's say, something about clients, and we will use this. But knowledge graph, it's very good because it can use like for, let's say, the one problem with RAG system in that case is just you cannot ask questions that cannot be answered by, let's say, by vector database. So if that vector database is not the answer, then RAG system is, let's say, cannot give you nothing. But knowledge graph solves this by the thing that you have some relationship and you can use that relationship. But in our case, it's, let's say, we use this RAG system just to improve the retrieving. So basically, we want to use our financial advisor to find faster the documents. And because we have a lot of documents for a lot of companies, just this improves a lot of their speed of work. So it's just for this purpose, just finding fast the document for that company they need and just look at it. Okay, so yes, we use a specific tool for logging. So basically use, let's say, we use something from MLflow. There is a specific package that can be used for, let's say, for logging. And also we try now to, let's say, use another system because there is now popular hype on this, on different logging systems. And once again, okay, so we tried Anfuse and it's not working so good in our case. Why? Because it takes a lot of time. So basically it's just have a big lag between you can see what happened. So we cannot, or we try it and let's say it was good in some cases, but in some cases it's taken a lot of time to just review the logs. And we remain on MLflow till now, but we try a lot of different methods. Just the problem is that different, let's say, frameworks that use for, let's say, how to track how your system works, they have a lot of different components that you need to change in your code just to implement them. So this takes time, and let's say we don't have time for this. So we just try in our, let's say, when we have more time to improve system, we try to use different approaches, but currently we use MFlow, just basic MFlow, because this was from the beginning. Yeah. Okay, so if you don't have questions, thank you.